2,500,000 years ago, Andromeda Galaxy. Not far from the galactic core, a giant star is dying, the last seconds of her life, accompanied by a devastating explosion. Trillions of tons of hot plasma fly apart in a huge cloud, turning nearby planets and satellites into dust. A powerful electromagnetic pulse pierces outer space in all directions. After millions of years, it will reach Earth. 1885 year. Earth. The attention of all astronomers on the planet is riveted to the amazing astronomical event. A bright flash in the Andromeda Nebula briefly outshines nearby stars, shone with its radiance. This amazing supernova is called S Andromeda, and its anomalous parameters have puzzled astronomers for a long time, into a dead end. But just 6 months later, the star is rapidly dimming and soon disappears from the sky forever. Unfortunately, at the time of the outbreak, the generally accepted ideas, the structures of the universe were far from modern ones. At that time, astronomers did not yet know how to measure distance to cosmic bodies. Therefore, the bright spot in the constellation Andromeda, also known as the object M31, was thought to be an ordinary reflection nebula on the outskirts of the Milky Way. Meanwhile, the emergence of new ones, more powerful telescopes, and the development of space technology gradually changed. Already in the 20s of last year, centuries of observation by Edwin Hubble and other astronomers have proven that the Andromeda Nebula is another galaxy much like the Milky Way. It's been a while since then. About a century, and during this time, science has advanced far. It is currently known that the Andromeda Galaxy has a spiral structure and contains approximately 1 trillion stars. Moreover, its diameter exceeds 150,000 light-years, and the mass is relatively small and amounts to from 800 billion to 1.5 trillion solar masses, about the same as the Milky Way. Counts that it is connected with the abundance of red dwarfs and less dark matter in its composition. Like all spiral galaxies, Andromeda has a massive core at its center, consisting of millions of closely spaced stars. Its radiance is so great that it blinds observation instruments, not allowing to distinguish individual luminaries. Because of this, the remnants of the supernova, 1885, known as S Andromeda, it took a long time to find, although there were surviving records, clearly indicated that it had exploded nearby. From the center of the galaxy, it was only in 1988, 103 years after the legendary flashes at a slight distance from the core a small nebula was discovered, standing out as a dark spot against the backdrop of the dazzling central area. Using spectral analysis and modeling, it was possible to reliably establish its own motion, that it is a remnant of S Andromeda. Thus, this space object became the first supernova discovered outside the Milky Way. Looking closely at the central part, Andromeda, it is easy to notice its unique difference from other spiral galaxies. It has an unusual double nucleus, the origin of which has not yet been fully studied. The brighter and more extensive part is located slightly away from the geometric center of the galaxy and is a giant supercluster of many bright stars with a total size of about 7 light-years. The second part is closer to the center, but is noticeably dimmer and smaller. Its diameter is approximately 1.3 light-years. It is assumed that this area hides a supermassive black hole inside, approximately 50 million times heavier than the Sun. The nature of such a strange phenomenon remains a subject of scientific debate. According to some assumptions, in the distant past, M31 swallowed and dispersed a fairly large satellite galaxy, and the bright region is the remnant of its core. Other hypotheses say that the center of Andromeda also has a single structure, but it is separated by a strip opaque dust creating an unusual optical effect. Due to the remoteness and inconvenient location of the galaxy, in space, collect enough data to confirm. This or that hypothesis is not yet possible. Meanwhile, continuing to move through the central region of Andromeda, you can also notice one of the most mysterious objects of this galaxy. You can read its difficult-to-pronounce name on their screens. And the key feature of this celestial body is that it is practically impossible to see even with the most powerful optical telescope. However, everything changes if you use X-rays. In this part of the spectrum, this luminary is a bright point in the galaxy. Observations show that the object is a system of two components, one of which is low-mass neutron star. Its radius is only a few tens of kilometers, and a complete rotation around its axis occurs approximately in 3 seconds. The second luminary of the system is larger, but relatively a dim object, most likely a red giant. Calculations show that the total mass of both components does not exceed 3 solar, and the distance between them very little. Every 4 hours, the neutron star is eclipsed by its own stellar companion, due to which the power of its radiation drops sharply and then returns to previous values. It is also very likely that due to the small distance between the stars, a neutron star gradually absorbs his companion, because of which he constantly increases mass. According to calculations, this process will last for several tens of millions of years. As a result, the second luminary will be torn apart by tidal waves, forces, and turn into a bright and hot ring, nebula. Meanwhile, this amazing object is only one from the many luminaries that tightly surround the core of Andromeda. Together they form a massive bulge with a diameter of about 12,000 light-years, having a noticeably elongated shape. The M31 also has a pronounced bar. However, it is turned towards us with its narrow side and is practically invisible from Earth. According to calculations, its length is about 17,000 light-years, and the width is about 6,500 light-years. In total, in the central part of the Andromeda galaxy, about 30% of its total mass is concentrated. As we move away, gradually, we can see that the edges of the bar serve as the basis for 2 giant spiral arms, with majestic coils embracing the center of the galaxy. At the same time, there are darker gaps between them, the width of which significantly larger than the Milky Way and reaches 13,000 light-years. Calculations show that the arms of Andromeda contain approximately 56% of the stellar mass of the galaxy, and also some amount of dark matter. Under the influence of gravity, interstellar dust and gas are concentrated in the arms, forming many star-forming regions. Over time, these gas and dust clouds turn into scattered clusters and associations, containing a great diversity of young stars. Their light is reflected and scattered by cosmic nebulae, allowing the galactic disk to shimmer with a fantastic, colorful, and in one of these clusters there is an amazing luminary called AE Andromeda. It is one of the brightest stars in the galaxy, and is a hot blue giant with a luminosity which changes without any apparent pattern. Such objects are called bright blue variables and are extremely rare. Currently, only a few dozen are known. Such luminaries, due to the enormous temperature and pressure, the outer layers, and Andromeda are in a constant state of instability, equilibrium, and the processes occurring in the depths of the star are largely chaotic and unpredictable. Streams from time to time, hot plasma collide with each other, generating the brightest flashes that change luminosity, object by several tens of times. Hypothetically, the most powerful of them could increase brightness several million times. This phenomenon is called a pseudo-supernova, and can occur at any moment. Measuring the parameters of such an unstable star, combined with the huge distance, is an extremely difficult task. However, with the help of modern high-precision telescopes, it became known that the mass of II Andromeda lies in the range from 50 to 120 solar masses, and the radius at the peak of the pulsation is approximately 55 times the radius of our star, which is only slightly smaller than the orbit of Mercury. At the same time, the temperature, its surface is close to 20,000 Kelvin, and its brightness exceeds that of the Sun by 700,000 times. Like all blue giants, Andromeda emits a powerful stellar wind, the speed of which, according to calculations, can reach 100 kilometers per second. Because of this, the object loses about 2 quadrillion tons of matter per second, which means its mass decreases annually by an amount similar to 10 planets like Earth. However, for such a large star, this is practically unnoticeable. After all, Andromeda will complete its evolution much earlier. Then the losses from the stellar wind will reach at least 0.1% of its mass. The fact is that despite its small size, by cosmic standards the age is 2 million years AI. Andromeda has already passed most of its life cycle. According to calculations, the star will explode within the next million years. Supernova, leaving behind a black hole surrounded by extensive gas and dust nebula. When talking about the age of stars, one cannot help but notice that they are distributed unevenly throughout the galaxy. In this way, we can look into the past Andromedas and see how it was formed. The oldest stars are about 11 to 13 billion years old, concentrated in the central part of the galaxy. In contrast, the disk and spiral arms mainly contain younger stars that have formed approximately 3 to 4 billion years ago. Here, numerous star cradles are located, and very young stars born only a few million years ago. This means that in the first stage of its evolution, M31 was much smaller in size and its shape resembled ellipse. Also, analyzing the parameters of individual luminaries of Andromeda, it is possible to define such an important, but at the same time rather conditional concept as galactic habitable zone. It is believed that the concentration of stars in the central parts of Andromeda, as well as high radiation levels and unstable orbits, potential exoplanets, make this zone unfavorable for the emergence of life. At the same time, remote planetary systems located on the periphery, galaxies are too poor in heavy elements, which leads to a shortage of rocky planets like Earth. Therefore, only the intermediate region, galaxies, can be considered hypothetically habitable. It is in such a zone, at a distance of about several tens of thousands of light years from the center, the galaxy contains a small, dim object known like Mega ML7. It is a red giant with a mass is relatively small and amounts to about 50% from the Sun. In 1999, thanks to a lucky coincidence, astronomers have managed to record the phenomenon of microlensing, during which they were able to study in detail such an inconspicuous and distant cosmic body. As a result of the measurements, it was possible to determine the mass and spectrum of the luminary, as well as the temperature of its surface, which amounted to approximately 3,700 kelvins. But the most important observation was the rhythmic deviations, trajectory of the star from the main direction of its motion. Such fluctuations are considered a sign. The possible presence of a fairly massive satellite has been revealed. The alleged object was named Mega ML7b, is currently considered a potential exoplanet. If the existence of this celestial body will be confirmed, then it will become the first exoplanet in the history of astronomy, discovered outside the Milky Way. There is little information about this object yet, but calculations show that it is highly likely to be a gas giant, with a mass of about 6.3 Jupiter masses. There is also information that according to the diversity of chemical elements, this system is most likely not inferior to ours, which means there is a high chance of meeting the most different types of planets, not only gas giants, but also rocky celestial bodies similar to the Earth. When observing the Andromeda Galaxy, one thing that catches the eye is one more feature. This is a multitude of star clusters and associations, the number of which is much higher than in the Milky Way. In total, about 460 globular star clusters are known in M31, and about 10,000 scattered, as well as several dozen large stellar associations. Some of them are concentrated in the center of the galaxy, others are scattered in the halo, others settled right in its spiral arms. And one of the largest and most noticeable structures is the cluster NGC 206, located almost at the very edge of the galactic disk. Previously, this association was considered globular cluster, but now due to its size, it has received a higher status and has be called a stellar association. In this region of space, with a radius of about 200 light-years, concentrated around 300 extremely luminous stars and countless more. Less noticeable, with a total mass of about 200,000 solar masses. Their combined luminosity is so great that the association, visible from Earth in an amateur telescope along with the nucleus and the arms of the galaxy. According to observations, NGC 206 was formed as a result of mergers of at least two large gas and dust fields, nebulae separated by a dark band of interstellar dust. One of them is about 10 million years old, the other. It is noticeably older and was formed about 50 million years ago. A single giant nebula has become a point of gravitational attraction for interstellar gas, which led to the formation, a grandiose region of star formation. Over time, some of the components of its luminary will dissipate into the surrounding space, while the rest form a large globular cluster. The galactic disk, M31, contains many similar formations, and not all of them were originally formed within its borders. Many large stellar associations are thought to be the remnants of great cosmic catastrophes of the past. According to calculations over the entire period of its existence, Andromeda has swallowed up more than 100 satellite galaxies. Some of them disappeared without a trace. Others turned into giant star streams. The most grandiose of all can be considered the collision with an object unknown to us under the index M32. This compact elliptic galaxy is located above the disk of Andromeda, only 17,000 light-years away from him. Its diameter is about 8,000 light-years. And for such a small size, this galaxy has a fairly high mass, about 1 billion. Sunny. At the center of M32 is a supermassive black hole. The hole is about 2.5 million times heavier than ours. Stars, which is surprising for such a compact object. In fact, M32 is just a remnant of a much larger, large galaxy that experienced a major catastrophe. Data from the Spitzer Space Telescope indicate that about 800 million years ago, a large satellite galaxy. At high speed, it broke through the disk Andromeda, leaving. There is an impressive hole in one of the spiral arms. During this clash, M32 lost most of its stars, and it is unlikely to restore its former appearance. Maybe. It is assumed that it could have been full-fledged, an elliptical galaxy or a small spiral galaxy, of which only the central part remains. In addition to M32, Andromeda has about 30 satellite galaxies connected to it by invisible threads of gravity. The brightest and largest of them is M110, whose diameter is about 15,000 light-years. Most of the rest are related to dwarf spherical galaxies and are located within 1 million light-years. Nevertheless, Together, they form the Andromeda subgroup, which is part of the local group. Its other members are the Milky Way and its surroundings, as well as the Triangulum Galaxy and some other objects. The inexorable forces of attraction gradually draw the local group together, center, which is why the Andromeda Galaxy is rapidly moving in our direction, covering more than 300 kilometers every second. In a few billion years, Andromeda will merge with the Milky Way, forming a giant elliptical galaxy. Grandiose. Gravitational forces will move the luminaries of both wanderers, unpredictably scattering them across space. By this time, our planet will be mercilessly burned by the destructive rays of the dying, the sun, or disappear altogether in the ocean of hot plasma. What will happen to humanity then? It is almost impossible to predict. Will we populate other worlds having changed beyond recognition under the impact of their natural conditions, or disappear without trace like many ancient species is unlikely? We can answer this question with confidence.